Math 2, Semester 2, Power Standard 5 Mastery Exam Review. Number 1. Find the value of x in the triangle below when we know that tangent 64 equals x over 15. Round to the nearest hundredth if necessary. So anytime that we're finding a missing side using trigonometry, those are the problems where we want to cross multiply. So I'm going to put the tangent 64 over 1. If it helps you, maybe put the tangent 64 in parentheses to remind yourself that the tangent is kind of glued to the 64. And then you're going to cross multiply. So 1 times x is x, and then 15 times tangent 64 goes on the other side of the equal sign. Make sure your calculator is in degree mode. If you're using the Calculate 84 app, you have to hit mode, and then you could just press the word degree, and then hit enter, and then your calculator will be in degree mode. And then you just type it in. So 15 times tangent 64, and then it says to round to the nearest hundredth, so I'm seeing 30.754 in my calculator. So the fact that there's a 4 after the 5 tells me to stay the same as opposed to rounding up. As far as units go, they had feet on the one side, so since I just found a side of the triangle, I'm going to use feet as opposed to degrees. If I had found the measure of an angle, then I would put degrees. Number 2, find the value of x in the triangle below when we know that sine x equals 40 over 50, round to the nearest hundredth if necessary. So we are finding a missing angle using trigonometry. Anytime we find a missing angle using trigonometry, that's when we want to use the inverse sign. So basically the only way to cancel out sine is to do inverse sine. And whatever I do to one side of the equation, I have to do to the other side of the equation. So again, the little sign to the -1, that's inverse sine. It cancels out regular sine, so you're just left with x on the left side of the equation. And then in your calculator, to access the inverse trig functions, you have to hit the second button first, and then in this case, I would hit the side button. And then 40 divided by 50, and then we're rounding to the nearest hundredth. And in my calculator, I get 53.130, so that 0 tells me to stay the same as opposed to rounding up. Since I just found an angle measure, I'm going to add a degree symbol on my answer for my units. Looking at number 3, we want to solve for y. So we're going to want to just get y all by itself by doing order of operations backwards. So in order to get rid of that division by 4, I'm going to multiply both sides of the equation by 4. So I get 4x equals negative y minus 7 because the 4's cancel out. Then I need to get rid of the negative 7 by adding 7 to both sides of the equation. Remember, whatever you do to one side, you have to do to the other side to keep it balanced. Then that negative sign in front of the y, that's like a -1. So to get rid of a -1, you're going to divide by -1 on both sides of the equation. So then you could technically leave your answer as 4x plus 7 all divided by -1, but you also could just make this a -4x and this a -7 to make it a little bit less complicated looking, a little bit more simplified. So the 4x divided by -1 turns negative, and then the 7 divided by -1 turns negative. And there you go. On 4, we're going to find x, and they gave us this equation right here. So tangent 28 equals 1454 over x. So we're going to put the tangent 28 over 1. I'd recommend putting the tangent 28 in parentheses to remind yourself that it's kind of glued together. So you're going to cross multiply x times tan 28 equals 1 times 1,454 is just 1,454. And then we have x times tangent 28. So to undo multiplication, you have to do division. So tangent 28, remember, is kind of glued together. So you divide both sides of the equation by tangent 28. And then type it in to the calculator, making sure you're still in degree mode. If you haven't changed it out, it shouldn't have magically changed on its own. but just a reminder to be in degree mode, otherwise you're going to get all those problems wrong. And we get about 2,734.58. Because in the calculator it was 0.576, so the 6 tells me to round up to 0.58. As far as units go, they were talking about feet, so let me add feet on my answer to have the proper units. Number 5, solve the system of equations. So in this particular problem, both equations are not solved for a single variable, so it would be easiest to do elimination. I'm going to choose to eliminate the y's because then I can get away with only multiplying one of the equations by a number instead of both of the equations by a number. So if I multiply that top equation by 2, I will get the y values to have opposite coefficients, which is perfect because I want them to cancel out. So 2 times 6x is 12x. 2 times negative 2y is negative 4y. 2 times negative 18 is negative 36. Then we're going to add down the column. This top equation is kind of done with now, so it's just that typed second equation and then the blue equation that I wrote. Negative 4x plus 12x is 8x. 4y plus negative 4y cancels. And then 12 minus 36, or 12 plus negative 36, is negative 24. Undo multiplication by doing division, and you get x equals negative 3. Now remember, that's only half the answer. Take your x value, plug it back into either one of the equations would be fine. So I'm going to plug it back into the top equation. So wherever I see an x, I'm going to plug in a negative 3, like that, and then you just do the math. So negative 18 minus 2y equals negative 18. And then add 18 on both sides. Negative 2y equals 0. Divide by negative 2, divide by negative 2. Y equals 0. At the very end, make sure you write your answer as an ordered pair. X, comma, y in parentheses. Number 6, solve the equation. So whenever you're doing an absolute value equation, you have to isolate the absolute value bars first by doing order of operations backwards. So I have to add 4 to both sides of the equation first before I worry about that 2 up in the front. Speaking of that 2 up in the front, do not distribute it into the absolute value bars. You want to undo multiplication by doing division. So that's how you get rid of that 2. So absolute value of 5x minus 9 equals 6. And then now that the absolute value bars are isolated, this is the part where we split into 2 separate equations. So we have 5x minus 9 equals 6. So the first equation you just kind of leave alone, except you drop the absolute value bars. And then the second equation, you still drop the absolute value bars, but you switch the sign. So you make it equal to negative 6 instead of positive 6. And then you just solve the 2 equations like normal. So add 9. 5x equals 15. Divide by 5, divide by 5. X equals 3. And then on the other equation, add 9. 5x equals 3. Divide by 5, divide by 5. X equals 3/5. And remember, it's fine to have a fraction as an answer, just make sure it's reduced. Number 7, solve the inequality. So since it's an absolute value inequality, we have to isolate the absolute value bars first by doing order of operations backwards. So I'm going to add 8 to both sides of the equation, both sides of the inequality. So then I get absolute value of negative 4x is greater than 20. Once the absolute value bars are isolated, you can decide if it's a greater problem or a less than problem. So I'm looking at this sign right here. Since it's a greater than sign, This is going to be an OR problem, greater, so a union problem. With absolute value inequalities, kind of like with absolute value equations, you have to split it into two problems. So you drop the absolute value bars and leave the first one alone, like that. And then for the second inequality, still drop the absolute value bars, but this time you're going to switch the direction of the inequality symbol and you're going to switch the sign on your number. So less than negative 20. Now we solve like normal. Anytime you're solving an inequality, if you multiply or divide by a negative number, you have to flip the direction of the sign. So I just divided by negative 4, so I need to flip the direction of the sign. And then on the other side, same thing. I'm dividing by negative 4. So since I'm dividing by a negative sign, I have to flip the direction of the inequality symbol. So there's my answer. X is less than negative 5 or x is greater than 5. On number 8, you have a fraction equals a fraction. So probably the easiest way to solve that type of problem is to just cross multiply. 6 times x plus 3 goes on one side of the equation. And then 3 times parentheses x minus 1 goes on the other side of the equation. And then you just solve like normal. So distribute to get rid of your parentheses. Distribute to get rid of your parentheses. And then just keep going. So I'm going to get all my x's on one side by subtracting 3x from both sides of the equation. And then I'm going to get rid of that positive 18 by subtracting 18. So 3x equals, what is that, negative 21? And then divide by 3. And we get x equals negative 7. On 9, negative 2 times 3x is negative 6x. 8 times x is 8x. 8 times negative 3 is negative 24. Minus 8x. Minus 8x, minus 8x. So negative 14x equals negative 24. And then divide both sides by negative 14. And then at the end here, reduce the fraction. So 24 and 14 are both divisible by 2, and the negative divided by a negative cancels out. So 24 divided by 2 is 12, 14 divided by 2 is 7, so we should get 12 sevenths. And then that last one, distribute the 1/3, so negative 20 equals 6 plus 1/3 x. And then we can subtract 6 from both sides. So negative 26 equals 1/3 x. And then to get rid of a 1/3, normally you would divide both sides of the equation by 1/3, but dividing a fraction by a fraction is the same as multiplying by the reciprocal. So I'm actually going to multiply both sides of the equation by 3. That'll be a little bit better. So 3 times negative 26 is negative 78. And then x is left on the other side of the equation. So that's it.